Hi, folks. Welcome to this talk for DevOps.js Conference. We're going to talk about atomic deployment for JavaScript and TypeScript hipsters. So, right before starting, a little bit of information about what atomic deployment and immutable deployment are. So, in an atomic deployment, you take two versions of an existing application and you just deploying the changes between these two versions, but everything is self-contained. So you can take a whole archive of um, version at any point of time, and everything is self-contained, and you don't have to worry about anything else about that. This is what makes Netlify so successful in the past, because suddenly you just had to push a branch on your version server like GitHub or whatever, and it was automatically deployed on your production server in a staging URL like mybranch/myapp.mydomain.com. So it's really powerful because you just have to push some changes in any kind of branch. You automatically have a lot of previews directly accessible. And each time you update your branch, like updating your PR, the preview updates itself the same way. So it's definitely useful, especially when deployment is a painful process, when you have to worry about dependencies and building and so on and blah blah blah. So what is the hipster ways to this kind of atomic or immutable deployments? My idea is that I want to keep it working. I want to stick to this principles of atomic and immutable deployments. I want it to be functionable, workable, and compatible with any hosting provider, whichever it was. And I want to stick to the simple developer experience. Like, I just want to push my branch and my preview is automatically deployed or updated. And that's all. And I don't care about how to use it and how to work with it and so on. So what are the expected features on this one specifically? So I want it to be configurable because I don't want to revamp the whole process for each project. I want to have something that is easily deployable to any kind of repository, and where I just have to tweak a few variables to configure it for this very specific project at a time. I want it to be vanilla hosting compatible, so working on any kind of hosting provider in the wild. I want some kind of micro CI integrated, like deployment dependencies and building and so on. Everything handled by the solution by itself, so I don't have to worry about anything about that. But without the test suite and so on, it doesn't care. I want a no to minimal downtime on deployment. So to keep it really working. So I don't want to break something on the production just because I pushed a brand that suddenly didn't build or something else. So I want some kind of safeguards at some points to be sure that everything is nothing is can be down at some point. And I want it to be auto publishable. So I just want to push it in a branch and boom, my branches, my preview associated to my branch is automatically updated. So I'm Matt, folks. I'm a developer experience engineer at Always Data, which is a hosting provider, an independent one. So my responsibility in at Always Data is working on the developer experience, more specifically on the CLI and the tools associated to the platform itself. So what I will show you is definitely the foundation of our automated deployment process with atomic and immutable deployment features baked in directly. It's currently in process of development in the CLI, but it will be available soon. So I'm really happy to share it with you because it's definitely the result of my search. So let's dive into the code to see that working. Our premises for this very specific talk are: we will work in the server and all in a server, which means whatever it is, container, VPS, bare metal, whatever you want to share the accounts on a hosting provider, I don't care. But the idea is that I just want to have in the same place the web hosts and the repositories that are responsible for the atomic deployment, versioning, and so on. It's not mandatory for this solution, but it's definitely simpler to explain. I will rely on a web hosting Unix system account like www for any Debian-based distribution, but let's say everything will be handled by the same system user at some point, repo and web hosts. We will rely a lot on SSH remote access. So you need an SSH remote access to your solution. And I won't use webhooks for this one. Not that I don't like them, but it's totally out of scope for this talk. So I will talk about them a little bit in conclusion. So obviously, when I talk to them again, we will have reached the conclusion. So bootstrapping it, the idea is that you rely on Git basics. So I will SSH directly onto the server in my container with my hosting account, and I will make sure that I'm in the /var folder, because in /var there's a www folder. This is the document root for our web server engine, like Apache or Nginx or Traffic or whatever you want. I don't care. I will initialize a repository, a bare repository, in the very same folder at /var/repo. A bare repository is, give or take, the same thing that you have in the .git folder in your working tree, but you just have the different hashes and elements dedicated to Git, and not the overall content of your source trees, because I don't care on the server to give access of the code base at any time. So if I check, I still have in my /var folder 2 subfolders: the repository in the bare format and the www one ready to handle our web apps. So get back locally on my computer. I will cd in my project folder, wherever you want to store your project. It's totally up to you. I will create a new application, for example, using Vite with template. So I will create an application named My App. So it's k-folded in My App, and now I can directly enter into my application. Then I will link the previously created repo inside my container to this app project locally. So I will git init the application, git add everything that is available in it, and making the first initial commit. So everything is in the root commit, in the first commit at the initial commit, first one, initializing it. So I will add a remote deploy, which is pointing through SSH to the container and the var repo folder we created before. Why deploy and not origin? Because we will probably want to keep origin for our versioning server, like GitHub or GitLab or whatever you want. And you can have as much remote as you wish in Git. So why not name this one deploy, because it's ready to handle the deployment process, and keep origin for the origin one, the upstream regular one. So I can git push deploy main. So I push on deploy the main branch, and I've got a feedback from Git saying, okay, on containers var repo, I created a new branch main pointing to the main branch. Success. Okay, so now let's configure it. We want the project to be configurable, so let's go back through SSH to the var repo. So we are still in our bare repository, and if I check the git config locals, I can see that I have a very few configuration keys. So, which is interesting, because I don't want to rely on a new YAML, whatever fucking configuration file in my source tree. I want to have a few configurable variables that I want to tweak just for this very specific repository dedicated to deployment. So why not relying on git config tool to do so? So the format is always the same, realm.key/value. So we can create a git config local, because we want to keep it locals, dears.build dist, because in this project, it's a vid project, so vid will build a dist folder, and this is this dist folder that I want to deploy on my web apps for my web host and so on. I don't want to deploy the whole source tree, just the dist folder. So I specify that for this very specific project, and I use git config to do so. There is a dist build, and I can use so. So I recommend to use a DS or whatever. Don't use anything that Git already rely on, like core and so on, because there is a risk of overriding existing keys. But you can definitely rely to it to store your very own configuration. It's open. It's okay. So if we check, it's okay. It's already stored. So let's hook it. So everything right now will occur in the SSH var repo folder. So a few words on Git hooks. Git hooks are a mechanism that allow you to react to some events occurring in the life cycle of your Git repository. So in the whole list, which is very long, of different events available, there is a few ones that are interesting. And one specifically is really interesting. It's a post-receive hook, which is often dedicated to push the code to production. Interesting. This is exactly what we are trying to do. So let's rely on the post-receive hook. Let's have a quick look at it. So it's a hook that is reacting to Git push events. When any updates branches are coming, it executes on the remote repository. Excellent. And once after all the refs have been updated, which is interesting, I could push whole branches. My repository will handle them and will react to all branches one by one. So I could definitely update and deploy each branch one by one every time I receive a Git push event if it contains different branches. But if there is only one, it's okay. So it reads lines from stand-in, and it's an automated process. So I will write it in Bash. You could rely on Python or Node or Dino or whatever you want to do so, but it's just automating a bunch of different terminal commands. So Bash is a great tool to do so. So we check we're still in the repo, we create look at the post-receive file and make it executable. So let's initialize it. It's a Bash content. We have a while loop to read the standing for each line, and in each line we've got three kind of information: one line, one branch, and we've got three information: the old revision commit, the new revision commit, and the reference, which is obviously the name of the branch. So we can equate working on the branch, blah blah blah. Okay, so we have to set up the environment. So we have to retrieve the path to the Git per folder on the server itself. I could hardcode it, but I want it to be agnostic, so I have to detect it. It's a bit tricky. I don't deep dive into it, but you've got it. We've got access to the Git folder, and we pushed inside the Git folder like a CD. So we enter the Git folder to execute the rest of the commands. We check if we have DS deploy configuration key, and we didn't define this one. So we can fall back to a folder at the same level of the Git folder in the VVV directory, which is exactly what we have, /var/VVV for the deployment. So we've got a deployment here. We check that the folder is already ready to handle the rest. And we're ready to continue. So we can, for each branch, for each one, we can set up the branch. We are making some tricks to improve the readability. So we have a ref name, which is removing the ref's heads prefix. We use just a 8-cars comic, and we make a temp dir to host our source tree for this very specific branch. So we're also making a link dir to the deploy dir ref name, which is a Riemann readable path, because I don't want to configure all my web hosts to /var/vvv/a commit ID, but I want them to be pointing to var vvv, my branch name. So I can just move a link, which is just a pointer, from the ref name to the current commit dedicated to this branch. So it will be better. So we use a link to do so, and we prepare the link name. Okay, so now we have a working tree in a temp folder. So check out the work tree. We use the work tree command, which is like a checkout, but in a more powerful way. So we add a new work tree to this temp folder based on this current branch, and we pushed into it to move into this working tree. We have to handle the build process. So we check if we have a build there configured. This is the case. We defined it before, so we have it. Otherwise, it's just a current folder. We test if we have a package design available. If so, we test if we have a package lock. If so, we make a clean install because we are clean people. Otherwise, let's do an install, but remember to commit your log files. And then we can run the build script if the script is present. If not, it's okay. It's perfectly fine. If the build fails, the script will exit and we will go to the next branch. And everything is protected like that. So go next. A quick word on Unix hard links. The idea in the atomic process, if you remind correctly, is that I just want to copy the files that have changed from my previous version to this one. So I want I don't want to copy everything and duplicate the content. So my idea is to say, okay, let's check if we have a previous version of this branch. So we want to check where is the forking point from the main branch or from the originating branch, and we want to check if there is a commit dedicated to that. If so, if the file hasn't changed between the version, this originate branch and this new one, just copy this one. Just hard link to this version. Otherwise, copy a new version. It will be more performant, faster, and definitely easier to maintain. And making just you to copy the changes, but each version will be self-contained. This is why we don't rely on symbolic links, but we prefer hard links to do so. So it meant that we have to find a git command ancestor. So let's say that we are in the fixed branch. If we are there, we can guess that the forking point is a C1 commit. But if we ask Git, hey, what is the forking point for my current branch? Git don't track anything because Git don't really store a tree of the different branches, but just a list of commits. So you have to rely on yourself to do so. So you have to get the revision list from the tip of your branch to the main branch and the initial commit. Then you have to check for each one of these commit if it's a valid ancestor, so if it's a forking point from a previous branch. And if so, then you could consider that this commit, if it's still in a branch, could be used as a base for the deployment. So how to do so in code? We've got the rev list thanks to the rev list command, and for each revision, so each commit in this list, we go back in history, and for each of them, we check if it's a possible ancestor for my branch for this specific revision. If it's the case, so if it's the forking point, then let's check that it's still in a branch and that this branch were deployed before. So is this revision still available? If so, then we could consider that we can, like we fork the code, we can fork the deployment and use this folder as a base folder for the revision. Otherwise, just unset the rev and we will just deploy from scratch, and it's okay. It's perfectly legit to do so. So if we got a common ancestor, then we just create, add a few options to AirSync, which will be our deploy tool, to say, okay, for this specific copy task, use this folder as a base, and if the file didn't change between this folder and the new one, just make a hard link between the two. So let's go to deploy. We will rely on async as you expected. So we will deploy from the working dir build directory inside it. So my dist directory inside my work tree, and we will deploy it to my deploy directory, the revision ID commit. We rely on checksum to do so with the async option activated. So hard links activated. It's if it's reliable in this context, and so on. After that, we can just popped from the working folder, remove it from the Git repository because we don't need it anymore, and we are clean people, so we are cleaning behind us. And then we can publish it, which means creating the links between the reference name and the revision name, so moving the pointer of the symbolic link of the branch name to the correct commit, ensure everything is okay, creating the link, and then after that, we restart the server. So in this demo, I fake the restarting. So I just kill the existing server previously launched, and I randomize a port and launch an HTTP server to pointing to this new production link that I created before, and that is pointing to my new commit. And ta-da, everything is okay. So this is for the publishing. So let me show you how it works. Go back to my local folder. I update my application. I check that I'm still in my application. I check out a new branch named fit/update name, switching to this branch, editing the application, committing the content with a fancy commit message update name, and then I can ship it. So I git push deploy fit update name. So I push to deploy my fit update name branch, and it said that, okay, I deploy branch to var vvv. We're working on the branch fit update name. I'm preparing the work tree. So we are moving to the work tree in a detached state. Here we are installing the npm packages. So we are building thanks to npm run build, thanks to Vite. So we are producing the dist folder. We found the deploy base commit because the branch were forked from the main branch. And we are deploying this dist folder to var vvv, my reference commit name. Then we can make the link from the fit update name to the final commit ID, and I restart the application. And if I check, I can assure you that it works, and in less than 60 lines of bash code for something as successful as Netlify. This is just insane. So what are the real use cases? Because I have said I faked the restarting process. So you will probably have some kind of actions like creating or updating the website with the correct URL, like mybranch_name.myapp.mydomain.com, probably performing some DB actions like migration and so on, invalidation of cache, restarting the website, whatever you want. So you have to do so, wrap them in API calls, replacing the fake content of restarting the HTTP server. But if it's just static files like we have here, it's just creating a new vhost in your web engine, and it's okay. So that's great. What about webhooks? As I said before, you can use them mainly just to automate the pushing from the origin remote to the deploy remote. So each time you push to GitHub or GitLab or whatever your upstream versioning server, thanks to webhooks, you can automate the retrieving process in the deploy server branch. I wrote a blog post about it if you want. So you can use them for that, and it's perfectly okay. It's perfectly fine. It's just, reducing the friction in terms of developer experience. Some few tips for wrapping. Keep it simple and stupid. I make it really agnostic. I don't want to make it really clever or so on. Once again, it's just less than 60 lines of bash code. So make it really KISS, and it will be really easier to maintain and to adapt to a lot of different applications. Use git config a lot to store your variable and configuration process tweakings and so on. Abstract any changes to your web hosting configuration in API calls using CLI, using API, using whatever you want. And you can for sure rely on Dino or Node.js as a build system. Thanks to the package JSON file, you can create a lot of scripts to run to make sure the dependencies are installed, run pre-build process, build process, post-build process, even on complex application written in, I don't know, Python, Ruby, Rust, whatever you want. But you can definitely use Node.js as a CI engine for the build process. So thanks again. Thanks for having me today, and I hope you enjoy the rest of the conference. Bye-bye.